In this video I want to talk about the graphs of the binomial distribution. Oops. And to demonstrate these graphs, I'm going to start by talking about this little spinner type thing. It's got an arrow. You can see the arrow there. And basically with these spinners, you flick the arrow around and it can either land on one of the sectors. It can land on A, or it can land on B, or it can land on C. And the sectors are different sizes. So obviously sector A takes up half of the circle there. So there's a 0.5 chance of it landing on there, a 0.3 chance of it landing on sector C, and a 0.2 chance of it landing on sector B. So imagine the arrow being spun around. So that's what we're looking at. Now, say we did, and of course this is an example of success or fail, and what we'd be looking at here is that what's the chance of it landing on the sector that's got a probability of 0.2. So in other words, you know, how many times, is it going to land on sector B, which has got a probability of 0.2, if we did 15 trials. So here we are, 15 trials, and the probability of it landing on sector C is 0.2, okay, and then we've got the probabilities of it landing in that sector a certain number of times out of 15. Now obviously if you do it 15 times, it's not going to land on that sector many times. So over here in this part of the graph, okay, it's almost impossible for you to spin that arrow around 15 times and get 12, 13, 14 or 15 of those spins landing on that sector, okay, because that's what it's demonstrating there. So that's almost a probability, okay, is very small. Okay, I won't say impossible because nothing's impossible, but it's very small. And you can see that, okay, they're barely registering on this graph. In that situation with that sector B being so small, probability of only 0.2, you'd expect if you spun 15 times, you're typically going to get 3 out of 15, or 2 out of 15, or 4 out of 15 is your most likely ones. You can see they've got the highest probability there. So we call this graph positively skewed. Okay, positively skewed. And sometimes you see these as curved graphs, so I'll just change pen colour for a moment and use green here. So you can imagine here, you can almost have a curve going up and down like so. So that positively skewed type graph looks something like that, whether it's a histogram or a smooth curve like that, okay? And whenever you get a probability of less than 0.5, you get that positive skew. Okay, so if probability is less than 0.5, the graph is positively skewed. Okay, and you can see this on pages 522 and 523 of the text. You can see that also in greater detail than what I'm showing you here. All right, next scenario is looking at sector A. Okay, so we've had a look at sector B. Sector A has got a probability of 0.5. What would you expect here? We'd expect something like this. Okay, and to describe the shape here, we could say that it's actually symmetrical. So we'll draw a curve, and I can get something like this. Okay, it's not skewed in either direction. Okay, if n is quite large, so 15 trials, okay, that's important. And the probability is 0.5, okay, the chance of us getting 7 out of 15 or 8 out of 15 times landing on that sector, on sector A, is quite high, okay, because it's a 50-50 chance. Out of your 15 trials, there's a high chance that you'll get a 7 or an 8, okay, times it'll land on that one. And you can see it falls away either side. The closer you get away from that middle section, okay, so if we take 11 as example, so the chance, what this is saying is that the chance of it landing on that sector 11 times out of 15 is down here, is less than 0.05. Okay, if I read across to there. So it's only a very small chance. Okay, so typically we get that symmetrical shape, spell that. When the probability equals 0.5, or it's very close. Okay, the third scenario, we'll say I create one big sector now that's worth 0.8. So if I was to shade in that sector, and I might do that, so look at that. Okay, let's now divide this into two big sections. Okay, so we've got our arrow that will be spinning around. Okay, and of course the chance of it landing on sector A is 0.8 because it's the largest sector. The chance of it landing on sector B is 0.2. So if we did that 15 times, okay, you'd expect the chance of it landing on that, and our probability is 0.8, that is our sector A. The chances of getting lots out of the 15 landing on sector A is quite high. So see here, 12 out of 15 times, it's nearly a 1 in 4 chance, okay, of it landing on that sector A 12 out of the 15 times. And also with these other high figures, the 11 and the 13, quite a high probability that out of the 15 spins, we're going to land on that sector A. Down here, halfway, 7 and 8, okay, 50-50 out of 15 tosses, we've got a very low probability. And that stands to reason, okay? If we're going to spin this 15 times, the chance of it landing on B 7 or 8 times out of the 15 is quite small. Hence the probabilities are small there. So back to our descriptions, we can now draw a graph here, like so, and we say that is negatively skewed. Okay, so it's sloping the other way. And typically you get this if you've got n is large, okay, and probability is greater than 0.5. Okay, and the closer it is to 1, the more skewed it will be to that right-hand side. Okay, so there's some descriptions of the binomial graphs. Once again, as I said, page 522, 523. There's some information on those. There's not a whole lot of questions. They're quite straightforward, the ones that are there. But you could look probably at questions 29 to 32. On pages 525 and 526.